So I'm Satnam, and thanks a lot for coming to this session. It takes a while to figure out where things are, and you came all the way, so I really appreciate that. So I'm going to talk about threat hunting. I was just curious, how many of you do threat hunting? Awesome. I think after the session I would love to have a lot more conversation and hear from you. So let's get started on threat hunting here. So I think I can't teach the expert over here the threat hunting, but the key point I want to make here is most of the threat hunting what we have been doing so far is mostly a reactive approach. So we typically start from existing alerts or from a hypothesis and then go hunt for it, right? And it's not really a full-time activity as such. Even if it is, then the returns comes out to be less, and you have to wait for it. So and most of the time the threat hunting boils down to some sort of anomaly detection. So you look at for suspicious processes in a Windows operating system, or any hypothesis, you make it and you hunt for it. Ultimately it boils down to hunting for anomalies and outliers. Now what's wrong with that? The problem with that is there could be too many false positives, and you again need to invest a lot of time to investigate them. So another problem with that is you have your number of alerts which are into hundreds, and as a security analyst, when you investigate them, you are able to investigate only 5 to 10% of them. So what we need to do is a little more of a systematic approach. So this is a quote from Sense that 47% of the organizations are doing threat hunting more of ad hoc basis. We need more of a systematic approach. So how do we do that? So I'm going to propose something which is completely different. Think about it like machines and algorithms working for you. So as an analyst, you are the driver, you give your hypothesis, and the machines and algorithms take over and they chase a presence of threat. So they are doing a hunting for you. So how can we do that? Well, let's go back to our old concepts, but in the reincarnation format of that. What do I mean by that? Let's use the active approach, and that active approach is deceptive security. Deceptive security, deception is not a new term. It has been there from 90s. All the honeypot, honey words, honey tokens, all honey star dot star, we all know from 90s. But with this new paradigm of computing power, the software networking, and the machine learning and data science together, we can actually make a deception which works at enterprise level. And that's what is changing the game. We could project the deception at a scale which can imitate at the enterprise level into thousands of decoys, hundreds of breadcrumbs, lures, and it has enough density, enough variety, which was not possible earlier. So if we use that, and along with the data science, that will give us a lot more proactive approach. So you will say, enough of high level, give me a crisp and clear methodology. How do I do it? So here is the science behind it. The step one is your own dashboard, your own Splunk security app, or it could be your Splunk ES app from where you start. So you have a list of notables, and those notables and the hosts are being ranked with based on certain criteria, right? Now what we need to do is leverage data science to figure out what are the good candidates for deceptive security. So what do I mean by that is, let's say, if I make a chart of the hosts and the incidents in my network, and if I rank them, then I look at the tail end, because the tail end is the one which, as an analyst, I don't have time to investigate them. And I want the power of machines and the deceptive security to chase them. So what I would do is take the tail end and give it to the data science engine. The data science engine is going to figure out that what kind of decoy, what kind of breadcrumb, what kind of lure is really useful for that. And then it would recommend that, and it would be deployed in the network using the deception platform. Now, what I'm talking is more of a science. We could use open source as well. The point here is we want to leverage the deception to validate a presence of a threat. So if the threat is there, then it would indicate that, and then we can go back and revise the ranking of incidents and alert, and all that can happen in the automated fashion. And next, it will change the ranking so that as an analyst, you can go ahead and investigate that particular incident or that particular host. So not only that, if it is beyond certain threshold, then we could also do automated remediation. We could integrate with adaptive response framework and just isolate that particular host and take some more severe action for that particular VLAN as well. So let's see a particular example. Okay, so in this example, what you see is there is a bar chart which shows the host ranking, which is before using this particular approach. Now, using the data science, we figure out what are the good candidates for threat hunting. We see that, okay, in this particular case, it is excessive failure login, and this happened for this particular host, which is indicated over here, highlighted here. So we take that particular host, and this is all done in an automated fashion. I'm just giving a one simple use case. Now, there could be various hypotheses, which as an analyst, we make those hypotheses. See, for an example, if there are large number of excessive failure login, this may not be a true positive, because maybe there is a script and admin forgot to turn it off, and it is just firing lots of alerts, right? So it's just one of the hypotheses. The another hypothesis is like, if I have a failure login notable which is coming from a multiple sources and going to a single target, then this could be something to worthwhile to investigate, right? So I'm just giving a one of the hypotheses, and you may have 5 more hypotheses. So these hypotheses are traditionally put it to hunt for the anomalies and alerts, right? Now what we'll do is we will use these hypotheses to find what are the good candidates for threat hunting and give it to the deceptive security. So what do I mean by give it to deceptive security is we deploy the deception around it, and in this particular example, what is happening is there were 6 different users from 6 different IP addresses trying to access one particular target host, and that happened to be a database server. Now, what we could do from a deception point of view, we could actually put a lot of breadcrumbs around it. We could also put a fake database server. So now, if there is a threat, if there is an adversary in that VLAN, in that enterprise network, then there should be some action. And the beauty of it, this approach is, if we get an alert, this is solid, true positive. We don't need to worry about it. I mean, this is a 0% false alarm, because nobody's supposed to go there. That's a decoy. And if you get an alarm from there, then there is something fishy going on. So now we can take that alert, do a triage with the other security events, and we can change the ranking of the hosts and also of the incidents, and then we investigate them. So in this approach, what we have done is we have leveraged both, number one, hypothesis knowledge from security analysts. Number two, the power of algorithms and the power of machines doing a job for us. And that's what we should be doing. So in a summary, what I've talked about, we said, threat hunting so far has been on an ad hoc approach. What we need to do is some more systematic approach. And in this approach, which is much more proactive, we can actually leverage deception and the data science together to hunt for the threats which are there, which are in the enterprise network. Those are hidden, but we can surface them using this combination. Okay, so we have a demo and cool t-shirts to give away at our booth. Please visit our booth, and I'll be happy to take the questions offline. Thank you very much. Thanks for coming all the way here. Thank you.